crawled up in the, oh my god,
Algorithm needs to distinguish.
fiberglass, freaking
Find which
insulation. Oh my god, that's a lot of work. I got this stupid box plugged in. Anyways, I got that fiberglass shit in my lungs. But,
built-in function object
oh, I can't even make my point.
do not implement there.
I make dudes feel so insecure when they see my picture, whatever, of my abs, that they gotta click on the video to then judge me and then make jokes about it on other people's streams. And this time I cheated. I didn't cheat. I said I never check the chat, but this time I did. And this time I ran like a stupid script. And I know who, whatever. I'm glad to like be in your head. It's kind of cool. Free rent. Anyways, I think I'm just gonna like keep this shirtless thumbnail from now on.
Description of a particular function.
Like, if it makes people insecure, so they gotta look at themselves. I mean, that's what I'm here to do. So I don't know. I gotta get back to Linux.
That are not
And I also realized that Sublime Text is like extremely old.
the function.
And I've been using Sublime for more than 12 years. And I kind of realized that
Specification.
I'm getting old. And that sucks.
An abstract token.
I'm getting old. Damn it.
Or
To getting old. I don't know. It must have been the shirtless thumbnail. They made some people go, you know what? Forget about incognito mode. I'm just gonna click on it. I gotta click on it. And like, in the excitement you just had to click on the video, and you forgot to go into like incognito mode.
to built-in functions are encouraged to do so by
So I don't know, whatever. It's kind of funny.
to existing functions.
I gotta figure out Linux to get this running. So, I don't know, that's fun. So I'm gonna like, try to get Linux running. I'm gonna have Siri text-to-speech, the JavaScript standard. I got fiberglass in my lungs. It's horrible. I think the internet is faster though. I gotta check the stream. I think I was able to bump it up 500 kilobytes. Or megabits per second? I don't know. Or the stream is like dying, it's really laggy. I guess I'll find out. Of course this isn't working. Why would it work? It's all freaking crap.
The tail call takes no arguments and
I think it's working now.
performs the following steps when called. 1. Assert. The current execution context will not
And it's still working.
any ECMA script code or built-in functions. The invocation of course
So I don't know.
of this abstract operation will
I'm writing a JavaScript engine. I wrote it like 7 years ago.
any such evaluation
7, 8 years, I don't know. And I'm converting it to 64-bit.
3
And I'm getting off Windows and onto Linux.
call must
And I'm dealing with Linux and all
created with the currently
the character that Linux has, because it's filled with character.
function or use those resources in support of the target function. 6e
I don't know. I gotta try to get this running.
6 point
That's about it. So I'm gonna get going.
body statement list yield
I'm gonna change the other video though to
1 static semantics early errors script body comma it is a syntax error if the lexically declared names of script body contains any duplicate entries, comma it is a syntax error if any element of the lexically declared names of script body also occurs in the are declared names of script body statement list, comma it is a syntax error if statement list contains super
what did Chip say?
super as eval code that is being processed by a direct eval. Additional early error rules for super with indirect eval are defined in 192.1.1, comma it is a syntax error if statement list contains new target unless the source text containing new target is eval code that is being processed.
It's like rectus abdominis I hear.
The error rules for new target indirect eval are defined in 192.1.1.
So like everybody has a 6-pack.
List with argument is true, comma it is
To put a little context to it, because I said 6-packs are genetic and 8-packs are genetic whatever.
cap
Everybody has muscles underneath their skin on their abdomen. If they don't, they can't sit or bend back because they don't have muscles. So clearly everybody has muscles in their abdomen area. What I meant by genetic is how they look.
I
Because my abs are by no means perfect.
A
I mean like,
E of statement list with arguments and is true, comma
the left side is like slightly lower than the right side
is full sun
by a tiny amount, but it's really frustrating.
that is being
Because it'd be nice if I had perfectly like symmetrical abs, but apparently they're not. So that's like genetic. That's what I meant by abs are genetic.
target functions activation record exceeds the size of the call.
And there's like different styles of abs. Some people can only get a 4-pack, some people can get a 6-pack, and some people can get 8. I almost have an 8, but it's not a defined line, so like I can't really count it as 8. I gotta like bend my stomach a little bit, and then you can kind of see 8, but it's not really 8. So I'm like genetically stuck
It's a boolean. It is defined
to having only a 6-pack. And if you watched your weight and you did some sit-ups or something,
directive return
and you stopped judging other people by their looks and making fun of it, well, there's nothing funnier than making fun of someone who's attractive, because that's pretty funny.
4 script records
But like, then you could find out if you have a 4-pack, a 6-pack, or you might even have an 8-pack. Who knows? Lose some weight, go to the gym, get fit. It's really simple.
the realm within which this script
It is literally really simple.
a script code
I don't know why that makes people so uncomfortable,
this script load
but I'm happy to make you uncomfortable,
string and
so you can look at yourself and grow as a human being.
old module record
So I don't know.
contain 2 different records with the same host defined. Anything default value is empty. Field reserved
Chatbot called it rectus abdominis.
6 1 5.
Someone like name the other stream of that. I just gotta remember.
The abstract operation parse script takes argument source text ECMA
Let's make a copy of this word
realm a realm
because I'm gonna forget.
and anything and returns a script record or a non-empty list of syntax error objects. It creates a script
Rectus abdominis. That's the word for the day.
It performs the following steps when called. 1.
Alright, I gotta get Linux running. This is taking way too long.
Script 2. If script is a list of errors, return script. 3. Return script record. Realm.
Crawling in attics sucks.
Implementation may parse script source text.
And I didn't even have enough ports on the stupid switchbacks.
Text.
I gotta, whatever.
To the point where this specification
Deal with it later.
script upon that source text. ECMA International 2024 365.
I gotta find some music. Focus.
Script record. The abstract operation. Argument script record. A script record. And returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. 1. Let global env be script record. 2. Let script context be a new ECMA script code execution context. 3. Set the function of script context to null. 4. Set the realm of script context to script record. 5. Set the script or module of script context to script record. 6. Set the variable environment of script context to global env. 7. Set the lexical environment of script context to global env. 8.
I gotta set the pause screen, whatever. Or actually, I'll just switch. I gotta find out how much lag there is.
Context onto the execution.
Because I bumped up the stupid rate.
Context is now the running execution context. 11. Let script be script record. 12. Let result be completion. Global declaratio. An instantiation. Script. Global env. 13. If result is a normal completion, then a set result to completion. Evaluation of script. B if result is a normal completion and result. Then
27 seconds of lag. So I think the internet is faster.
Stack 15. Assert the
I gotta check the Google, whatever website, whatever.
context that is now on the top of the execution context stack as the running execution context. 17. Return result. 6. 1. 7 global declaration instantiation. Script. env. The abstract operation global declaration instantiation takes argument script, a script parse node, and env, a global environment record, and returns either a normal completion containing unused
AI makes it so easy to make little scripts.
and context is being
Even if it doesn't work perfect.
in which bindings are to be created.
It never works perfect.
1. Let
It's easier than spending an hour trying to write something stupid.
var
So I don't know, chatbot is slightly useful.
for each element name of lex names.
Like in a pinch.
Declaration name is true. Throw a syntax error exception. B if env has lexical declaration name is true.
But production code, never with chatbot. Like, that'd be ridiculous.
env has restricted global property name. D if his
Could YouTube just load?
syntax error exception 4. For each element name of var names. Do if env has lexical declaration name is true. Throw a syntax error exception 5. Let var declarations be the var scope.
It actually says excellent connection.
Functions to initialize be a new empty.
So I'm trying to bump it up.
Let declared function names be a new empty list. 8. For each element D of var
Bitrate.
first list order. Do 66. ECMA International 2024. Note 1. When an execution context is established for evaluating scripts, declarations are instantiated in the current global environment. Each global binding declared in the code is instantiated. A. If D is not either a variable declaration, a for binding, or a binding identifier, then I. 2. 3. Assert. D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. Note, if there are multiple function declarations for the same name, the last
I'm waiting to see if it's lagging.
sole element of the bound names of D. If declared function names does not contain fn, then let fn definable.
I could get done with Linux. It's taking way too long.
If fn definable is false, throw a type error exception. 3. Append fn to declared function names. 4. Insert D as the first element of functions to initialize. 9. Let declared var names be a new empty list. 10. For each element D of var declarations, do if D is either a variable declaration, a for binding, or a binding identifier. Then I for each string vn of the bound names of D, do if declared funct iron names does not contain vn, then a let vn definable benv can declare global var vn b if vn definable is false. Throw a type error exception. See if declared var names does not contain vn, then I append vn to declared var names. 11. Note: no abnormal terminations occur after this algorithm step if the global object is an ordinary object. However, if the global
It's taking forever to like update.
behaviors that cause abnormal terminations in some of the following steps. 12. Note: an xb 3 2 adds additional steps at this point. 13. Let lex declarations be the lexically scoped declarations of script. 14. Let private env be null. 15. For each element D of lex declarations, do a note: lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of D, do I if this constant declaration of D is true, then perform env create immutable binding. dn true 2. Else perform env create mutable binding. dn false. 16. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments.
Nope, that's too high for bit rate.
Perform env create global function binding fn fo false. 17. For each string vn of declared var names, do a perform env create global var binding vn false. 8. Return unused. Note 2. Early errors specified in 1.6. 1. Prevent name conflicts between function var declarations and let const class declarations, as well as redeclaration of let const class bindings for declaration contained within a single script. However, such conflicts and redeclarations that span more than one script are detected as runtime errors during global declaration instantiation. If any such errors are detected, no bindings are instantiated for the script. However, if the global object is defined using proxy,
So like, I don't know,
a conflicting declaration
new router from 1 gigabit per second, not per second, a 1 gigabit switch box for Ethernet to 2.5 gigabit switch box.
properties
Now I can do
result in global bind
500 kilobits per second more than I could.
6.2 modules
So, it is slightly faster
item list
to use a higher kilobyte per second switch box.
2024 306
Very minimal.
export deck
I was hoping it'd be quicker, but whatever, it's a little bit faster.
return
I'm gonna take it to work.
name identifier name string literal 6 2 1 module semantics 6 2 1 static semantics early errors module body module item list, it is a syntax error if the lexically declared names of module item list contains any duplicate entries, it is a syntax error if any element of the lexically declared names of module item list also occurs in the are declared names of module item list, it is a syntax error if the exported names of
So I need to like,
any duplicate entries, it is
I installed cat or Kate, whatever it is.
module item list does not also occur in either the are declared names of module item list or the lexically declared name.
And
Item list contains super, it is a syntax
I don't think there's multi-line comments in Sublime. Not Sublime. The Sublime settings, whatever.
labels of module item list with argument is
So I'm gonna paste back the old file.
contains undefined break target of module item list with argument is true, it is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N.
And I'll just open the file from Windows or whatever in Mac. I was able to paste it from Mac and Windows, but like I can't just go to Sublime because I gotta check every line.
syntax error if all private identifiers valid.
Because like the smallest thing that doesn't pass makes it the biggest error.
It is a syntax error if is string well-formed Unicode. The SV of string literal is false.
Its preferences are here.
2 static semantics. Imported local names. Import entries. The abstract operation imported local names takes argument import entries. A list of import entry records.
Does this program have tabs?
It creates a list of all of the local name bindings defined by import entries. It performs the following steps when called. 1.
Just reopen it.
Names be a new empty list. 2. For each import entry record I of import entries, do a append I to local names. 3. Return local names. 6. 2. 1. 3 static semantics. Module requests. The syntax-directed operation module requests takes no arguments and returns a list of strings. It is
Another file like reset.
module empty. Return a new empty list. The duplicate exported names rule implies that multiple export default export declaration items. Note, within a module body is a syntax error. Additional error conditions relating to conflict.
You see if Sublime opens.
A check during module linking prior to evaluation of a module. If any such errors.
There we go. Everything works.
68. ECMA International 2024. Module item list. Module item. Return module request.
Man, that's annoying.
List. Module item list. Module item 1. Let module names be
I gotta go through line by line.
Let additional names be module requests of module item 3.
And ever so carefully
2. If module.
move things over.
Then I append
Oh, come on.
module names. Module item. Statement list item. Return a new empty list. Import declaration. Import clause from clause. Return module requests of from.
I should probably try to get the packages first.
Specifier. String literal. Return a list whose sole element is the SV of string literal. Export declaration. Export from clause. Return the module requests of from clause. Export declaration. Export named exports. Export variable statement. Export declaration. Export default hoistable declaration. Export default class declaration. Export default assignment expression. Return a new empty list 1 6 2 1. 4 abstract module records. A module record encapsulates structural information about the imports and exports of a single module. This information is used to link the imports and exports.
Where did they? I swear they were in here.
A module record includes 4 fields that are only used when evaluating a module. For specification,
I guess I'll paste them back.
the values of the record specification type and can be thought of as existing in a simple, object-oriented hierarchy where module record is an abstract class with both abstract and concrete subclasses. This specification defines the abstract subclass named cyclic module record and its concrete subclass named source text module record. Other specifications and implementations may define additional module record subclasses corresponding to alternative module definition facilities that they defined. Module
These should run. I don't think these are like
all
OS specific.
classes include at least those fields. Module record also defines the abstract method list in Table 42. All module definition subclasses must provide concrete implementations of these abstract methods. ECMA International 2024 369. Table 41. Module record fields. Field name. Value type. Meaning. Realm. A realm record. The realm within which this module was created. Environment. A module environment record or empty. The environment record containing the top-level bindings for this module. This field is
They did disappear.
space, an object or empty.
He's absorbing them.
28.3.
Okay, why doesn't that happen on Windows?
Module host defined. Anything default value is undefined. Field reserved for use by host.
Because on Windows, they just stay in this folder.
Information with a module. Table 42. Abstract methods of module records.
It's kind of annoying.
Requested modules. Host defined. Prepares the module.
Because now I don't have a backup copy.
Dependency.
Well, I do on this one, but whatever.
Get exported names. Export star set. Return a list of all names that are either directly or indirectly exported from this module. Load requested modules must have completed successfully prior to invoking this method.
One of these failed. I think it was this one then.
Resolve set. Return the binding
Yeah, Sublime's like absorbing them when I open it.
represented by a resolved binding record of the form module record string namespace. If the export is a module namespace object without a direct binding in any module,
Or it's deleting them. I'm not sure.
cannot be resolved, or ambiguous if multiple bindings were found. Each time this operation is
This is installed packages. I'm pasting them into installed packages on Linux.
alt, load requested modules,
I don't remember, I haven't installed packages in a while.
link, prepare the module,
It just sets Sublime up and it stays like that forever.
involving all module dependencies and creating a module environment record. Load requested modules must have completed successfully prior to invoking this method. Evaluate. Returns a promise for the evaluation of this module and its dependencies, resolving unsuccessful
So all the packages are copied over,
successfully,
I would assume.
or if it has already been evaluated unsuccessfully. If the
Most of the settings.
to handle the promised rejection and rethrow the evaluation error, link must have completed successfully prior to invoking this method. 70. ECMA International 2024. 6, 2, 1. 5 cyclic module records. A cyclic module record is used to represent information about a module that can participate in dependency cycles with other modules that are subclasses of the cyclic module record type. Module records that are not subclasses of the cyclic module record type must not participate in dependency cycles with source text module records. In addition to the fields defined in Table 41, cyclic module records have the additional fields listed in Table 43. Table 43. Additional fields of cyclic module records: field name, value type, meaning, status, new, unlinked, linking, linked, evaluating, evaluating async, or evaluated, initially new. Transitions to unlinked, linking, linked, evaluating, possibly evaluating async, evaluated, in that order, as the module progresses throughout its lifecycle. Evaluating async indicates this module is queued to execute on completion of its asynchronous dependencies, or it is a module whose field is true that has been executed and is pending top-level completion. Evaluation error: a throw completion nor empty. A throw completion representing the exception that occurred during evaluation, undefined if no exception occurred or if is not evaluated. DFS index: an integer or empty auxiliary field used
Was
if is either linking or evaluating. This non-negative number records the point at which the module was first visited during the depth-first traversal of the dependency graph. DFS ancestor index: an integer or empty auxiliary field used during link and evaluate only. If is either linking or evaluating. This is either the module's own or that of an earlier module in the same strongly connected component. Requested modules: a list of strings, a list of all the module specifier strings used by the module represented by this record to request the importation of a module. The list is in source text occurrence order. Loaded modules: a list of records with fields, a string, and a module record, a map from the specifier strings used by the module represented by this record to request the importation of a module to the resolved module record.
I might switch from Sublime.
With the same cycle root, a cyclic module record or empty. The
But not like today. I gotta figure out how to
founder of the strongly connected
all this records and shit.
you're not in a cycle. This would be the module itself. Once evaluate has completed, a module says the events. ECMA International 2024. 71. Table 43. Additional fields of cyclic module records. Continue.
This is really fancy.
A boolean, whether this module is individually a
It's like easier to read.
sample. If it's a source text module record can wait. Having an asynchronous dependent
When they put stuff in place of the white space.
evaluation. A boolean, whether this module is either itself asynchronous
Except this red text makes it difficult to read. I wish it was gray.
or in which this field
Yeah, it's like the same color as the strings. That's kind of cool. To invert it
3, 4. Top level capability.
when highlighted.
If this module is the of some cycle and evaluate,
So I'm gonna try to see if
this field contains the promise capability record for that entire evaluation.
I hate this auto formatting.
that is returned from the evaluate abstract method. This field will be empty for any dependencies of that module, unless a top-level evaluate has been initiated for some of those dependencies. Async parent modules, a list of cyclic module records. If this module or a dependency has true, and execution is in progress, this tracks the parent importers of this module for the top-level execution job. These parent modules will not start executing before this module has successfully completed execution, pending async dependencies, an integer or empty. If this module has any asynchronous dependencies, this tracks the number of asynchronous dependency modules remaining to execute for this module. A module with asynchronous dependencies will be executed when this field reaches 0 and there are no execution errors. In
Let's take text from this file,
42 cyclic module
paste in this file, close this one,
44, table 44,
and move it over chunk by chunk.
cyclic module records, method, purpose, initialize environment, initialize the environment record of the module, including resolving all imported bindings, and create the module's execution context. Execute module, promise capability, evaluate the module's code within its execution context. If this module has true in, then a promise capability record is passed as an argument, and the method is expected to resolve or reject the given capability. In this case, the method must not throw an exception, but instead reject the promise capability record if necessary. A graph loading state record is a record that contains information about the loading process of a module graph. It's used to continue loading.
So far so good.
Imported module.
It didn't crash yet,
State record has the fields defined in table 45.
but the font size should change.
International 2.
And didn't.
Table 45. Graph loading state record fields. Field name, value type, meaning.
That's what it didn't save.
A. Promise capability record. The promise to resolve when the loading process finishes is loading. A boolean. It is true if the loading process has not finished yet. Neither successfully nor with an error. Pending modules count. A non-negative integer. It tracks the number of pending host load imported module calls. Visited. A list of cyclic module records. It is a list of the cyclic module records that have been already loaded by the current loading process, to avoid infinite loops with circular dependencies. Host-defined. Anything default value is empty. It contains host-defined data to pass from the load requested module's caller to host load imported module. 6, 2, 1, 5, 1 load requested modules. Host-defined. The load requested module's concrete method of a cyclic module record module takes optional argument host-defined anything and returns a promise. It populates the of all the module records in the dependency graph of module. Most of the work is done by the
Try copying these all over.
It's an optional host-defined parameter that is passed to the host load imported module hook. It performs the following steps when called. 1. If host-defined is not present, let host-defined be empty. 2. Let PC be new promise capability, %promise %. 3. Let state be the graph loading state record. True. 1. Promise.
And it's still working.
Host defined. 4. Perform in a module loading. State. Module.
Copy over some more.
6, 2, 1, 5, 1.
It's probably just that one line where it picks the
Act operation.
cyanide theme or something.
A graph loading state record and module. A module record and returns unused. It is used by loads
Still works.
to recursively perform the actual loading process for module's dependency graph. It performs the following steps when called. 1. Assert.
Oh my god.
Euler's a cyclic module record.
How does it have no problem now, but earlier it was crashing out?
A append module.
Are you kidding me?
Requested modules count be the number of elements in module. C set state to state plus request
Oh wait, it is crashing out.
string required of module. Do I if module contains a record whose is required. Then 1.
This is over the theme still.
2. Perform in a module loading. State. Record 2. Else. Note the host defined
I keep hitting Command Escape or Control Escape
necessary to fetch.
to zoom out,
It is used. For example,
but that's for Windows
the correct fetch dest
or Mac.
link rel equals preloaders equals tags import Expressions never set the host-defined parameter. ECMA International
Really?
2073.
There it is.
Perform host load imported module. Module. Required. State.
There's something in here. Fucked it up.
Host load imported module will call finish loading imported module, which re-enters the graph loading process through continue module loading. 3. If state
It's because I don't have this in a quote
assert.
for the file path. Is that it?
Set state to state 1. 5. If state equals 0, then assert state to false. B for each cyclic module record loaded of state. Do if loaded as new, set loaded to unlinked. C perform. Call. State. Undefined. Undefined.
Turn off word wrap.
6, 2, 1, 5, 1. To continue module loading. State. Module completion. The abstract operation continue module loading takes argument state, a graph loading state record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It is used to re-enter the loading process after a call to host load imported module. It performs the following steps when called. 1. If state is false, return unused. 2. If a module completion is a normal completion, then perform in a module loading. State. Module completion. 3. Else assert state to false. B perform. Call. State. Undefined. Module completion. 4. Return unused. 6, 2, 1, 5. To link. The link concrete method of a cyclic module record module takes no arguments and returns either a normal completion containing unused or a throw completion. On success, link transitions this modules from unlinked to linked. On failure, an exception is thrown and this modules remains unlinked. Most of the work is done by the auxiliary function in a module linking. It performs the following steps when called. 1. Assert. Module is one of unlinked, linked, evaluating a sync, or evaluated. 2. Let stack be a new empty list. 3. Let result be completion in a module linking. Module, stack, 0, 4. If result is an abrupt completion, then a for each cyclic module record M of stack. Do I assert M is linking. 2. Set M to unlinked. B assert module is unlinked. C return result. 5.
Where the heck is word wrap?
1 of linked, evaluating a sync, or evaluated. 6. Assert stack is empty. 7. Return unused. 6, 2, 1, 5, 2, 1 in a module linking.
Oh, come on.
Index. The abstract operation in a module linking takes arguments module, a module record, stack, a list of cyclic module records, and index, a non-negative integer, and returns either a normal completion containing a non-negative integer or a throw completion. It is used by link to perform the actual linking process for module, as well as recursively on all other modules in the dependency graph. The stack and index parameters, as well as the modules and fields, keep track of the depth first search, DFS, traversal, 74, copyright sign, ECMA International 2024. In particular, is used to discover strongly connected components, SCCs, such that all modules in an SCC transition to link together. It performs the following steps.
Literally what I checked for. But where the heck is it?
Module record. Then, a perform module link. B return index. 2. If a module is one of linking,
I'm blind, I guess.
or evaluated, then a return index. 3. Assert. Module is unlinked. 4. Set module to linking. 5. Set module to index. 6. Set module to index. 7. Set index to index plus 1. 8. Append module to stack.
It's still on.
String required of module. Do a let required module be get imported module. Module.
Why can't they just have off?
2. In a module.
It says dynamic word wrap. Dynamic word wrap indicators.
Required module is
Static word wrap. Show static word wrap marker.
required module is one of linking.
How the fuck do you turn it off?
Evaluated. 2.
I want a word wrap off. Not just...
Contains required module. 3. If required module is linking, then set module to min. Module. Required module 10. Perform module initialize environment 11. Assert. Module occurs exactly once in stack 12. Assert. Module 13. If a module equals module, then a let done be false. Be repeat. While done is false, I let required module be the last element of stack 2. Remove the last element of stack 3. Assert. Required module is a cyclic module record. I've set required module to linked v. If required module and module are the same module record, set done to true 14. Return index 6, 2, 1, 5, 3. Evaluate. The evaluate concrete method of a cyclic module record module takes no arguments and returns a promise. Evaluate transitions this modules from linked to either evaluating async or evaluated. The first time it is called on a module in a given strongly connected component, evaluate creates and returns a promise which resolves when the module has finished evaluating. This promise is stored in the field of the for the component. Future invocations of evaluate on any module in the component return the same promise. Most of the work is done by the auxiliary function in a module evaluation. It performs the following steps when called. 1. Assert. This call to evaluate is not happening at the same time as another call to
Oh my god, it's so annoying. It's so dumb.
module is one of linked, evaluating async, or evaluated. 3. If module is either evaluating async or evaluated, set module to module. 4. If a module is not empty, then a return module. 5. Let stack be a new empty list. 6. Let capability be new promise capability.
How do I uncheck it?
7. Set module to capability. 8. Let result be completion in a module evaluation. Module stack 0, 9. If result
There we go.
for each cyclic module record m of stack. Do I assert?
I thought it was like you pick one or the other, but it looked like you could pick more than one, which means it's multi-select. So now it's off.
3. Set m to result. B assert. Module is evaluated. C assert. Module is result. D perform. Call. Capability. Undefined. Result. 0. Else. A assert. Module is either evaluating async or evaluated. B assert. Module is empty. C if module is false, then I assert. Module is evaluated. 2. Perform. Call. Capability. Undefined. Undefined. D assert. Stack is empty. 1. Return capability. 6, 2, 1, 5, 3, 1. In a module evaluation. Module. Stack. Index. The abstract operation in a module evaluation takes arguments module, a module record,
Cut over one by one.
module records, and index, a non-negative integer, and returns either a normal completion containing a non-negative integer or a throw completion. It is used by evaluate to perform the actual evaluation process for module, as well as recursively on all the other modules in the dependency graph. The stack and index parameters, as well as modules and fields, are used the same way as in a module linking. It performs the following steps when called. If a module is not a cyclic module record, then a let promise be module evaluate. B assert. Promise is not pending. C if promise is rejected, then I return throw completion. Promise D return index. 2.
The lag. I gotta restart this again.
Then if module is empty, return index. B otherwise, return module. 3. If module is evaluating, return index. 4. Assert. Module is linked. 5. Set module to evaluating. 6. Set module to index. 7. Set module to index. 8. Set module to 0. 9. Set index to index plus 1.
So it runs still.
To stack. 11. For each string required of module, do
Copy another chunk.
module be get imported module. Module required be set index 2. In a module evaluation, required module stack index. See if required module is a cyclic module record. Then I assert required module is one of evaluated.
There it is. Something in here.
2. Assert. Required module is evaluating if and only if stack contains required module. 3. If required module is evaluating, Then set module to min. Module required module I've. Else 1. Set required module to required module 2. Assert. Required module is either evaluating async or evaluated. 3. If required module is not empty, return required module v. If required module is true, then
It's literally the theme line. I think that's the only issue.
2. Append module to required module 2. If a module 0 or module is true, then 76. ECMA International 2024. AB. Assert. Module is false and was never previously set to true. Set module to true. See note. The order in which module records have their fields transition to true is significant. C16. 2. 1. 5. 3. 4. D. If a module equals 0, perform execute async module. Module 13. Else. A perform module execute module 14. Assert. Module occurs exactly once in stack 15. Assert. Module 16. If a module equals module, then a let done be false. Be repeat. World un is false. I let required module be the last element of stack 2. Remove the last element of stack 3. Assert. Required module is a cyclic module record I've. If required module is false, set required module to evaluated v. Otherwise, set required module to evaluating async v. If required module and module are the same module record, set done to true 7. Set required module to module 17. Return index. Note 1. A module is evaluating while it is being traversed by inner module evaluation. A module is evaluated on execution completion or evaluation.
How's this itself in the command line?
Or if it has asynchronous dependencies. Note 2. Any modules depending on a module of an asynchronous cycle when that cycle
I copy pasted it. It's not working.
execution of the root of the cycle via. This ensures that the cycle state can be treated as a single strongly connected component through its root module state. 6. 2. 1. 5. 3. To execute async module. Module. The abstract operation execute async module takes argument module, a cyclic module record, and returns unused. It performs the following steps when called. 1. Assert. Module is either evaluating or evaluating async. 2. Assert. Module is true. 3. Let capability be. New promise capability. Promise %. 4. Let fulfilled closure be a new abstract closure with no parameters that captures module and performs the following steps when called. A performance and module execution fulfilled. Module be return undefined. 5. Let unfulfilled be create built-in function. Fulfilled closure 0. 6. Let rejected closure be a new abstract closure with parameters. Error. That captures module and performs the following steps when called. A performance and module execution rejected. Module. Error. Be return undefined. 7. Let onRejected be create built-in function. Rejected closure 0. 8. Perform promise then. Capability. Unfulfilled. OnRejected 9. Perform module execute module. Capability 10. Return unused 6. 2. 1. 5. 3. 3. Gather available ancestors. Module. Exec list. The abstract operation gather available ancestors takes arguments module, a cyclic module record, and exec list, a list of cyclic module records, and returns unused. It performs the following steps when called. For each cyclic module record M of module, do. If exec list does not contain M and M is empty, then I assert M is evaluating async. ECMA International 2024 377. 2. Assert. M is empty. 3. Assert. M is true. I've. Assert. M. 0. V set M to M1 V. If M equals 0, then 1. Append M to exec list. 2. If M is false, perform gather available ancestors. M. Exec list. Return unused. 6. 2. 1. 5. 3. 4. Async module execution fulfilled. Module. The abstract operation async module execution fulfilled takes argument module, a cyclic module record, and returns unused. It performs the following steps when called. 1. If module is evaluated, then A assert module is not empty, B return unused. 2. Assert module is evaluating async. 3. Assert module is true. 4. Assert module is empty. 5. Set module to false. 6. Set module to evaluated. 7. If a module is not empty, then A assert module is module. B perform call module undefined. 8. Let exec list be a new empty list. 9. Perform gather available ancestors module exec list. 10. Let sorted exec list be a list whose elements are the elements of exec list in the order in which they had their fields set to true and in a module evaluation. 11. Assert all elements of sorted exec list have K are fields set to true, fields set to 0, and fields set to empty. 12. For each cyclic module record M of sorted exec list, do if M is evaluated, then I assert M is not empty. B else if M is true, then I perform execute async module MC else I let result be M execute module. 2. If result is an abrupt completion, then perform async module execution rejected M result. 3. Else 1. Set M to evaluated. 2. If M is not empty, then A assert M is M. B perform call M undefined. 3. Return unused. 6. 2. 1. 5. 3. 5 async module execution rejected module error. The abstract operation async module execution rejected takes arguments module, a cyclic module record, and error, an ECMA script language value, and returns unused. It performs the following steps when called. 1. If module is evaluated, then note when an asynchronous execution for a root module is fulfilled. This function determines the list of modules which are able to synchronously execute together on this completion, populating them in exec list. 78. ECMA International 2024. A assert module is not empty. B return unused. 2. Assert module is evaluating async. 3. Assert module is true. 4. Assert module is empty. 5. Set module to throw completion error. 6. Set module to evaluated. 7. For each cyclic module record M of module, do a performance and module execution rejected M error. 8. If a module is not empty, then A assert module is module. B perform call module undefined error. 9. Return unused. 6. 2. 1. 5. For example, cyclic module record graphs. This non-normative section gives a series of examples of the linking and evaluation of a few common module graphs, with a specific focus on how errors can occur. First, consider the following simple module graph. Figure 2. A simple module graph. Capital A, capital B, capital C. Let's first assume that there are no error conditions. When a host first calls a load requested modules, this will complete successfully by assumption, and recursively load the dependencies of B and C as well, respectively, C and none, and then set A equals B equals C equals unlinked. Then, when the host calls a link, it will complete successfully, again by assumption, such that A equals B equals C equals linked. These preparatory steps can be performed at any time. Later, when the host is ready to incur any possible side effects of the modules, it can call evaluate, which will complete successfully, returning a promise resolving to undefined, again by assumption, recursively having evaluated first C and then B. Each modules at this point will be evaluated. Consider then cases involving linking errors after a successful call to a load requested modules. If in a module linking of C succeeds but, thereafter, fails for B, for example because it imports something that C does not provide, then the original A link will fail, and both A and B's remain unlinked. C's has become linked, though. Finally, consider a case involving evaluation errors after a successful call to link. If in a module evaluation of C succeeds but, thereafter, fails for B, for example because B contains code that throws an exception, then the original A evaluate will fail, returning a rejected promise. The resulting exception will be recorded in
Okay, but why did it work on Windows?
evaluated. C will also become
On Windows, I don't have to put it inside the packages folder, and it keeps it cleaner.
it successfully completed.
They don't have to mix up
The exception ensures that any time
stuff with the packages. It's all like neat and tidy.
method, it will encounter the same
I
exception.
don't want to open them and then paste them in a folder. It's nicer to have them in the exe.
Hosts are not required to
I mean the file.
objects thrown by these methods. However, the specification enables such uses. Now consider a different type of error condition. ECMA International 2024 300
Because when there's a file like this, it's nice and neat, contained.
module capital A question mark in this
Whatever.
dependency on some other module, but no module record exists for that module. That is host load imported module calls finish loading imported module with an exception when asked for it. This could occur for a variety of reasons, such as the corresponding resource not existing, or the resource existing but parse module returning some errors when trying to parse the resulting source text. Hosts can choose to expose the cause of failure via the completion they pass to finish loading imported module. In any case, this exception causes a loading failure, which results in A's remaining new. The difference here between loading, linking and evaluation errors is due to the following characteristic. Evaluation must be only performed once, as it can cause side effects. It is thus important to remember whether evaluation has already been performed, even if unsuccessfully, in the error case. It makes sense to also remember the exception because otherwise subsequent evaluate calls would have to synthesize a new one. Linking, on the other hand, is side effect free, and thus even if it fails, it can be retried at a later time with no issues. Loading closely interacts with the host, and it may be desirable for some of them to allow users to retry failed loads. For example, if the failure is caused by temporarily bad network conditions. Now, consider a module graph with a cycle, figure 4. A cyclic module graph, BC. Here we assume that the entry point is module A, so that the host proceeds by calling a load requested modules, which performs in a module loading on A. This in turn calls in a module loading on B and C because of the cycle. This again triggers in a module loading on A, but at this point it is a no options A's dependencies loading has already been triggered during this load requested modules process. When all the modules in the graph have been successfully loaded, their transitions from new to unlinked at the same time. Then the host proceeds by calling a link, which performs in a module linking on A. This in turn calls in a module linking on B because of the cycle. This again triggers in a module linking on A, but at this point it is a no options A is already linking. B itself remains linking when control gets back to A, and in a module linking is triggered on C. After this returns with C being linked. Both A and B transition from linking to linked together. This is by design. Since they form a strongly connected component, it's possible to transition the status of modules in the same SCC at the same time because during this phase the module graph is traversed with a depth-first search. An analogous story occurs for the evaluation phase of a cyclic module graph. In the success case, now consider a case where A has a linking error. For example, it tries to import a binding from C that does not exist. In that case, the above steps still occur, including the early return from the second call to inner module linking on A. However, once we unwind back to the original inner module linking on A, it fails during initialize environment, namely right after C resolve export. The thrown syntax error exception propagates up to a link, which resets all modules that are currently on its stack. These are always exactly.
I don't think Linux has consoles.
Both A and B become unlinked. Note that C is left as linked. 80.
I might be able to copy it over.
National 2024. Alternatively, consider a case where A has an evaluation error. For example, its source code throws an exception. In that case, the evaluation time analog of the above steps still occurs, including the early return from the second call to inner module evaluation on A. However, once we unwind back to the original inner module evaluation on A, it fails by assumption. The exception thrown propagates up to A evaluate, which records the error in all modules that are currently on its stack. That is, the modules that are still evaluating, as well as via, which form a chain for modules which contain or depend on top. level await through the whole dependency graph through the async modular execution rejected algorithm.
I like this font. This one's good.
In the exception is recorded in both A and B's fields, while C is left as evaluated with no. Lastly, consider a module graph with a cycle, where all modules complete asynchronously. Figure 5. An asynchronous cyclic module graph. Capital A, B, C, D. Loading and linking happen as before, and all modules end up with set to linked. Calling evaluate calls in a module evaluation on A, B, and E, which all transition to evaluating. Then in a module evaluation is called on A again, which is a no-op because it is already evaluating. At this point, D is 0, so execute async module D is called and we call the execute module with a new promise capability tracking.
Is it not changing the font?
We unwind back to the inner module evaluation on B, setting B to 1 and B to true. We unwind back to the original inner module evaluation on A, setting it to 1. In the next iteration of the loop over A's dependencies, we call in a module evaluation on C and thus on D, again in no-op, and E as E has no dependencies and is not part of a cycle, we call execute async module E. In the same manner as D and E is immediately removed from the stack, we unwind once more to the original inner module evaluation on A, setting C to true. Now we finish the loop over A's dependencies, set A to true, and remove the entire strongly connected component from the stack, transitioning all of the modules to evaluating async at once. At this point, the fields of the modules are as given in
This is like a variant of source code, bro.
module fields after the initial evaluate. Call fields modules capital A, capital B, capital C, capital D, capital E, DFS index, DFS ancestor index, status, evaluating async evaluation, true, 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 async parent modules, double angle quotation.
I think you put like regular or italic or something.
C. Pending async dependencies. B and C. D. DMD. ECMA International 2024. 81. Let us assume that he finishes executing first. When that happens, async modular execution fulfilled is called.
I don't want to look it up. I just want it to work.
Is decremented to become what?
That's all I want.
Fields of the updated modules are as given in Table 47. Table 47.
No, Jebba is wrong.
Executing fields modules capital C capital E.
This was it.
DFS ancestor index status evaluating async evaluated async evaluation true true async parent modules A C pending async dependencies D is next to finish, as it was the only module that was still executing. When that happens, async modular execution fulfilled is called again and D is set to evaluated. Then B is decremented.
Now it should work.
Execute async module is called on B, and it starts executing. C is also
Source code, bro, then light.
starts executing, potentially in parallel to B if B contains an Y. T. The fields of the updated modules.
Nope.
8. Table 48. Module fields after module D finishes executing. Fields modules capital B capital C capital D DFS index DFS ancestor index status evaluating async evaluated async evaluation true 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 async parent modules A B C pending async dependencies. Let us assume that C finishes executing next. When that happens, async modular execution fulfilled is called again. C is set to evaluated and A is decremented to become 1. The fields of the updated modules are as given in Table 49. Table 49. Module fields after module C finishes executing. Fields modules capital A capital C DFS index DFS ancestor index.
It's not even on here.
Think evaluated.
I'd have to install it. Jebba is so fucking dumb.
84. Table 49. Module fields after module C finishes executing. Continued. Fields modules capital A capital C async evaluation true true async parent modules. Double
We have Helvetica. Is that free?
async dependencies. B then B finishes executing. When that happens, async modular execution fulfilled is called again and B is set to evaluated. A is decremented to become 0. So execute a sync module is called and it starts executing. The fields of the updated modules are as given in table.
This is way better than Windows font. Menu, whatever it is.
Modules, capital A, capital B, DFS index, DFS ancestor index, status, evaluating async, evaluated, async evaluation, true, async parent modules, double angle quotation mark, A, pending async dependencies. Finally, a finishes executing. When that happens, async module execution fulfilled is called again and A is set to evaluated. At this point, the promise in A, which was returned from A evaluate, is resolved, and this concludes the handling of this module graph. The fields of the updated module are as
Okay, I should just find it like this. That'd be useful.
module fields after module A finishes executing. Fields, modules, capital A.
Nope.
DFS ancestor index, status, evaluated, async evaluation, true, async parent modules, double angle quotation mark, pending async dependencies. Alternatively, consider a failure case where C fails execution and returns an error before B has finished executing. When that happens, async module execution rejected is called, which sets C to evaluated and ECMA International 2024 383, C to the error. It then propagates this error to all of the async parent modules by performing async module execution rejected on each of them. The fields of the updated modules are as given in Table 52. Table 52, module.
I don't know if this is it.
Error. Fields, modules, capital A, capital C, DFS index, DFS ancestor index, status, evaluated, async, C evaluation, true, async parent modules, double angle quotation mark, A, pending async dependencies, B, evaluation error, empty, C's evaluation error, A will be rejected with the same error as C since C will call async module execution rejected on A with C's error. A is set to evaluated. At this point, the promise in A, which was returned from A evaluate,
Typography, homeland security. What?
is given in Table 53. Table 53. Module fields after
What is homeland security?
modules, capital A, DFS index, DFS ancestor index, status,
Have a website page dedicated to typography. What even?
error, C's evaluation error. Then, B finishes executing without an error. When that happens,
Huh? I don't understand. What does
error, so it will not be added to the returned sort.
typography have to do with homeland security?
Of B.
Am I missing something?
The updated module.
Like, what is homeland security?
ECMA International 2024. Table 54. Module.
And typography have in common?
Erroring graph. Fields. Modules. Capital A. Capital B. DFS.
I don't get it.
Evaluated.
What even? What even?
Dependencies. Evaluation error. C's evaluation error. Empty. 6. 2.
USA. I'm making some water.
Is used to represent information about a module that was defined from ECMA script source text. 11. That was parsed using the goal symbol module. Its fields contain digested information about the names that are imported and exported by the module, and its concrete methods use these digests to link and evaluate the module. A source text module record can exist in a module graph with other subclasses of the abstract module record type, and can participate in cycles with other subclasses of the cyclic module record type, in addition to the fields defined in Table 43. Source text module records have the additional fields listed in Table 55. Each of these fields is initially set in parse module, Table 55. Additional fields of source text module records. Field name, value type, meaning, ECMA script code, a parse node. The result of parsing the source text of this module using module as the goal symbol. Context, an ECMA script code execution context or empty. The execution context associated with this module. It is empty until the module's environment has been initialized. Import meter, an object, or empty, an object exposed through the import meter meta property. It is empty until it is accessed by ECMA script code. Import entries, a list of import entry records. A list of import entry records derived from the code of this module. Local export entries, a list of export entry records. A list of export entry records derived from the code of this module that correspond to declarations that occur within the module. Indirect export entries, a list of export entry records. A list of export entry records derived from the code of this module that correspond to re-exported imports that occur within the module or exports from exporters' namespace declarations. ECMA International 2024, 85. Table 55. Additional fields of source text module records. Continued. An import entry record is a record that digests information about a single declarative import. Each import entry record has the fields defined in Table 56. Table 56. Import entry record fields. Field name, value type, meaning, star export entries, a list of export entry records. A list of export entry records derived from the code of this module that correspond to export declarations that occur within the module, not including exporters' namespace declarations. Field name, value type, meaning, module request, a string value of the module specifier of the import declaration. Import name, a string, or, namespace object, the name under which the desired binding is exported by the module identified by. The value namespace object indicates that the import request is for the target module's namespace object. Local name, a string, the name that is used to locally access the imported value from within the importing module. Note 1 Table 57 gives examples of import entry records fields used to represent the syntactic import forms. Table 57. Informative. Import forms mappings to import entry records. Import statement form, module request, import name, local name, import v from mod default, v, import as ns from mod namespace object, ns, import, x, from mod x, import, x as v, from mod x v, import mod. An import entry record is not created. An export entry record is a record that digests information about a single declarative export. Each export entry record has the fields defined in Table 58. 86. Copyright sign, ECMA International 2024. Table 58. Export entry record fields. Field name, value type, meaning, export name, a string or null. The name used to export this binding by this module. Module request, a string or null, the string value of the module specifier of the export declaration null if the export declaration does not have a module specifier. Import name, a string, null, all, or all but default, the name under which the desired binding is exported by the module identified by null if the export declaration does not have a module spec. I fear. All is used for exporters ns from mod declarations. All but default is used for export from mod declarations. Local name, a string or null, the name that is used to locally access the exported value from within the importing module null if the exported value is not locally accessible from within the module. Note 2 Table 59 gives examples of the export entry record fields used to represent the syntactic export forms. Table 59. Informative. Export forms mappings to export entry records. Export statement form. Export name. Module request. Import name. Local name. Export var v. Null v. Export default. Function f. Default. Null f. Export default. Function default. Null default. Export default. 2. Default. Null default. Export. X null x. Export. V as x null v. Export. X from mod x null. Export. V as x from mod x v null. Export from mod null all but default null. Export as ns from mod ns all null. The following definitions specify the required concrete methods and other abstract operations for source text module records. ECMA International 2024 387. 6, 2, 1, 6, 1 parse module, source text, realm, Host defined. The abstract operation parse module takes arguments source text, ECMA script source text, realm, a realm record, and host defined anything and returns a source text module record or a non-empty list of syntax error objects. It creates a source text module record based upon the result of parsing source text as a module. It performs the following steps when called. 1. Let body be parse text, source text, module. 2. If body is a list of errors, return body. 3. Let requested modules be the module requests of body. 4. Let import entries be import entries of body. 5. Let imported bound names be imported local names, import entries. 6. Let indirect export entries be a new empty list. 7. Let local export entries be a new empty list. 8. Let star export entries be a new empty list. 9. Let export entries be export entries of body. 10. For each export entry record EE of export entries. Do if EE is null, then if imported bound names does not contain EE, then 1. Append EE to local export entries. 2. Else 1. Let IE be the element of import entries whose is EE. 2. If IE is namespace object, then a note. This is a re-export of an imported module namespace object. Be append EE to local export entries. Else a note. This is a re-export of a single name. Be append the export entry record, i.e. import name, i.e. null EE, to indirect export entries. Be else if EE is all but default, then I assert EE is null. 2. Append EE to star export entries. See else. I append EE to indirect export entries. 11. Let async be body contains await. 12. Return source text module record, realm, empty, empty, cycle root, empty, async, false, empty, empty, new, empty, host defined, body, empty, empty, requested modules, import entries, local export entries, indirect export entries, star export entries, empty, empty, 6, 2, 1, 6, to get exported names, export star set. The get exported names concrete method of a source text module record module takes optional argument export star set, a list of source text module records, and returns a list of strings. It performs the following steps when called. 1. Assert. Module is not new. 2. If export star set is not present, set export star set to a new empty list. 3. If export star set contains module, then note an implementation map parse module source text and analyze it for early error conditions prior to the evaluation of parse module for that module source text. However, the reporting of any errors must be deferred until the point where this specification actually performs parse module upon that source text. ECMA International 2024. Assert. We've reached the starting point of an export circularity. B. Return a new empty list. 4. Append module to export star set. 5. Let exported names be a new empty list. 6. For each export entry record E of module, do assert. Module provides the direct binding for this export. B. Assert. It is not null. See append E to exported names. 7. For each export entry record E of module, do assert. Module imports a specific binding for this export. B. Assert. It is not null. See append E to exported names. 8. For each export entry record E of module, do assert. It is not null. B. Let requested module be get imported module. Module E. C. Let star names be requested module get exported names. Export star set. D. For each element n of star names, do I have same value, n, default, is false. Then, if exported names does not contain n, then A. Append n to exported names. 9. Return exported names. 6, 2, 1, 6, 3. Resolve export. Export name. Resolve set. The resolve export concrete method of a source text module record module takes argument export name, a string, and optional argument resolve set, a list of records with fields, a module record, and a string, and returns a resolved binding record, null, or ambiguous. Resolve export attempts to resolve an imported binding to the actual defining module and local binding name. The defining module may be the module represented by the module record this method was invoked on, or some other module that is imported by that module. The parameter resolve set is used to detect unresolved circular import-export paths. If a pair consisting of specific module record and export name is reached that is already in resolve set, an import circularity has been encountered. Before recursively calling resolve export, a pair consisting of module and export name is added to resolve set. If a defining module is found, a resolved binding record is returned. This record identifies the resolved binding of the originally requested export, unless this is the export of a namespace with no local binding. In this case, will be set to namespace. If no definition was found or the request is found to be circular, null is returned. If the request is found to be ambiguous, ambiguous is returned. It performs the following steps when called. 1. Assert. Module is not new. 2. If resolve set is not present, set resolve set to a new empty list. 3. For each record, R of resolve set, do, if module and R are the same module record and same value, export name, R, is true, then I assert, this is a circular import request. 2. Return null. 4. Append the record, module, export name, to resolve set. 5. For each export entry record E of module, do, if same value, export name, E, is true, then I assert, module provides the direct binding for this export. 2. Return resolved binding record, module, E. For each export entry record E of module, do, if same value, export name, E, is true, then ECMA International 2024 389. Note: get exported names does not filter out or throw an exception for names that have ambiguous star export bindings. I assert, I is not null. 2. Let imported module be get imported module, module, E. 3. If E is all, then 1. Assert, module does not provide the direct binding for this export. 2. Return resolved binding record, imported module namespace, I've, else. 1. Assert, module imports a specific binding for this export. 2. Return imported module resolve export, E, resolve set. 7. If same value, export name, default, is true, then I assert, a default export was not explicitly defined by this module, be return null. 8c. Note: a default export cannot be provided by an export from mod declaration. 9. Let star resolution be null. 10. For each export entry record E of module, do. I assert, I is not null. B. Let imported module be get imported module, module, E. C. Let resolution be imported module resolve export, export name, resolve set. D. If resolution is ambiguous, return ambiguous. E. If resolution is not null, then I assert, resolution is a resolved binding record. 2. If star resolution is null, then set star resolution to resolution 3. Else. 1. Assert, there is more than one import that includes the requested name. 2. If resolution and star resolution are not the same module record, return ambiguous. 3. If resolution is not star resolution and either resolution or star resolution is namespace, return ambiguous. 4. If resolution is a string, star resolution is a string, and same value, resolution, star resolution, is false, return ambiguous. 0. Return star resolution. 6. 2. 1. 6. For initialize environment. The initialize environment concrete method of a source text module record module takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. 1. For For each export entry record of module, do A assert I is not null. B let resolution be module resolve export. E see if resolution is either null or ambiguous. Throw a syntax error exception. D assert resolution is a resolved binding record. 2. Assert all named exports from module are resolvable. 3. Let realm be module. 4. Assert realm is not undefined. 5. Let env be new module environment. Realm. 6. Set module to env. 7. For each import entry record in of module, do a let imported module be get imported module. Module in be if in is namespace object. Then I let namespace be get module namespace imported module. 2. Perform env create immutable binding in true. 3. Perform env initialize binding in namespace 8c else 90 ECMA International 2024 I2. Let resolution be imported module resolve export in if resolution is either null or ambiguous. Throw a syntax error exception. 3. If resolution is namespace, then 1. Let namespace be get module namespace resolution. 2. Perform env create immutable binding in true. 3. Perform env initialize binding in namespace if else. Perform env create import binding in resolution. Resolution 8. Let module context be a new ECMA script code execution context. 9. Set the function of module context to null. 10. Assert module is not undefined. 11. Set the realm of module context to module. 12. Set the script or module of module context to module. 13. Set the variable environment of module context to module. 14. Set the lexical environment of module context to module. 15. Set the private environment of module context to null. 16. Set module to module context. 17. Push module context onto the execution context stack. Module context is now the running execution context. 18. Let code be module. 19. Let var declarations be the var scope declarations of code. 20. Let declared var names be a new empty list. 21. For each element d of var declarations, do a for each element dn of the bound names of d, do I if declared var names does not contain dn, then 1. Perform env create mutable binding. dn false. 2. Perform env initialize binding. dn
So I don't know what
append d
Source Sans Pro has to do with typography and homeland security.
env be null.
Primary colors. What even is this?
Do a for each element dn of the bound names of d, do
I didn't know homeland security was into design so much.
create immutable binding. dn true to else. Perform env create dn false. 3. If d is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then 1. Let fo be inst
Whoa, the lag.
and private env. 2. Perform env initialize binding. dn fo 25. Remove module context from the execution context stack. 26.
Accessibility exemption for the DHS seal.
2.
As designed, the DHS seal inherently fails the color contrast requirement for Section 508.
Module record
Accessibility.
argument capability.
Why the fuck would they fail a contrast requirement for Section 508?
Completion.
What's Section 508?
Steps when called.
Since the design of the seal is mandated by law, there's an exemption in place for its use. What? This is so dumb.
Context be
They really take this whole color code thing seriously. Like legally, that is amazing.
3. Set the realm of module context
Since the design, blah blah blah,
or module of module.
exemption has been issued by the Depart.
Module has been linked in declarations in its.
What was it, Department of Homeland Security? Yeah.
Set the variable environment of module context to module. 7. Set the lexical environment to
by the Department of Homeland Security Office of Accessible Systems and Technology.
if a modular's
And the DHS assistant.
is not present. Be
Wow, they really take color coding very seriously at the Department of Homeland Security. Maybe they should be more worried about Homeland Security than graphic design.
24,391. Decent.
Doesn't Homeland Security hunt down terrorists?
Resume the context that is now on the top of the execution.
I don't know. It's kind of like uncomforting that they take graphic design so seriously. They should be hunting terrorists or something. I don't know, what do I know?
If result is an abrupt completion, then
I did not expect this, so
return result 10. Else.
I'm gonna install the font later
Record. B perform a
and finish setting up Sublime later.
module context.
It's good enough for now.
Used 6, 2, 1, 7 get imported module referrer specifier. The abstract operation get imported module takes arguments referrer, a cyclic module record, and specifier, a string, and returns a module record. It performs the following steps when called. 1. Assert. Exactly one element of referrer is a record whose is specifier, since load requested modules has completed successfully on referrer prior to invoking this abstract operation. 2. Let
Alright, so Sublime works.
is specifier. 3. Return record 6, 2, 1, 8 host load imported module referrer specifier host.
Mostly works.
The host-defined abstract operation host load imported module takes arguments referrer, a script record,
See the file pass.
or a realm record, specifier, a string, host-defined anything, and payload, a graph loading state record or a promise capability record, and returns unused. Note an example of when referrer can be a realm record is in a web browser host. There, if a user clicks on a control given by button type equals button onClick equals import foo mjs click me button, there will be no active script or module at the time the import expression runs. More generally, this can happen in any situation where the host pushes execution contexts with null script or module components onto the execution context stack. An implementation of host load imported module must conform to the
Take us on here.
the host environment must perform finish loading imported module referrer specifier payload result, where result is either a normal completion containing the loaded module record or a throw completion, either synchronously or asynchronously. If this operation is called multiple times with the same referrer specifier parent, it performs finish loading imported module referrer specifier payload result, where result is a normal completion.
Alright, what?
Loading imported module referrer specifier payload result, with the same result each time.
I want to not restore the session, so do that first.
Value to be passed through to finish loading imported module.
Then I'll get the graphics to scale whatever the screen. Then I'll get the rest of it figured out. I don't know. This is so annoying.
But typically consists of performing whatever I/O operations are necessary to load the appropriate module record. Multiple different referrer specifier pairs may map to the same module record instance. The actual mapping semantics is host-defined but typically in normalize. Action process is applied to specifier as part of the mapping process. A typical normalization process would include actions such as expansion of relative and abbreviated path specifiers. 92. Copyright sign, ECMA International 2024. Six, 2, 1, 9. Finished loading imported module, referrer, specifier, payload, result. The abstract operation finished loading imported module takes arguments referrer, a script record, a cyclic module record, or a realm record, specifier, a string, payload, a graph loading state record or a promise capability record, and result. Either a normal completion containing a module record or a throw completion, and returns unused. It performs the following steps when called. If result is a normal completion, then if referrer contains a record whose is specifier, then I assert that records is result be else. I append the record, specifier, result, to referrer. If payload is a graph loading state record, then a perform continue module loading, payload, result, else. A perform continue dynamic import, payload, result, return unused. 6, 2, 1, 1, 0. Get module namespace, module. The abstract operation get module namespace takes argument module, an instance of a concrete subclass of module record, and returns a module namespace object or empty. It retrieves the module namespace object representing modules exports, lazily creating it the first time it was requested, and storing that in module for future retrieval. It performs the following steps when called. 1. Assert. If module is a cyclic module record, then module is not new or unlinked. 2. Let namespace be module. 3. If namespace is empty, then a let exported names be module get exported names. B let unambiguous names be a new empty list. C for each element name of exported names, do. I let resolution be module resolve export, name. 2. If resolution is a resolved binding record, append name to unambiguous names. D set namespace to module namespace create, module, unambiguous names. 4. Return namespace. 6, 2, 1, 1, 1. Runtime semantics, evaluation module, empty, return undefined. Module body, module item list. 1. Let result be completion, evaluation of module item list. 2. If result is a normal completion and result is empty, then a return undefined. 3. Return result, module item list, module item list. Module item 1. Let SL be evaluation of module item list. 2. Let S be completion, evaluation of module item. 3. Return update empty S SL. Note get module namespace never throws. Instead, unresolvable names are simply excluded from the namespace at this point. They will lead to a real linking error later unless they are all ambiguous star exports that are not explicitly requested anywhere. ECMA International 2024 393. Note the value of a module item list is T. Key value of the last value producing item in the module item list. Module item, import declaration. Return empty 16. 2. 2 import syntax. Import declaration. Import clause from clause. Import module specifier. Import clause. Imported default binding. Namespace import. Named imports. Imported default binding. Namespace import. Imported default binding. Named imports. Imported default binding. Imported binding. Namespace import. As imported binding. Named imports. Imports list. Imports list. From clause. From module specifier. Imports list. Import specifier. Imports list. Import specifier. Import specifier. Imported binding. Module export name as imported binding module specifier. String literal imported binding. Binding identifier. Yield. Plus await. 16. 2. 2. 1 static semantics. Early errors. Module item. Import declaration. It is a syntax error if the bound names of import declaration contains any duplicate entries. 94. Copyright sign. ECMA International 2024. 6. 2. 2. 2 static semantics. Import entries. The syntax-directed operation import entries takes no arguments and returns a list of import entry records. It is defined piecewise over the following productions. Module. Empty. Return a new empty list. Module item list. Module item list. Module item. 1. Let entries 1 be import entries of module item list. 2. Let entries 2 be import entries of module item. 3. Return the list concatenation of entries 1 and entries 2. Module item. Export declaration. Statement list item. Return a new empty list. Import declaration. Import clause from clause. 1. Let module be the sole element of module requests of from clause. 2. Return import entries for module of import clause with argument module. Import declaration. Import module specifier. 1. Return a new empty list. 6. 2. 2. 3 static semantics. Import entries for module. The syntax-directed operation import entries for module takes argument module, a string, and returns a list of import entry records. It is defined piecewise over the following productions. Import clause. Imported default binding. Namespace import. 1. Let entries 1 be import entries for module of imported default binding with argument module. 2. Let entries 2 be import entries for module of namespace import with argument module. 3. Return the list concatenation of entries 1 and entries 2. Import clause. Imported default binding. Named imports. 1. Let entries 1 be import entries for module of imported default binding with argument module. 2. Let entries 2 be import entries for module of named imports with argument module. 3. Return the list concatenation of entries 1 and entries 2. Imported default binding. Imported binding. 1. Let local name be the sole element of bound names of imported binding. 2. Let default entry be the import entry record. Module. Default. Local name. Local name. 3. Return default entry. Namespace import. As imported binding. 1. Let local name be the string value of imported binding. 2. Let entry be the import entry record. Module. Namespace object. Local name. Local name. 3. Return entry. ECMA International 2024 395. Named imports. Return a new empty list. Imports list. Imports list. Import specifier. 1. Let specs 1 be the import entries for module of imports list with argument module. 2. Let specs 2 be the import entries for module of import specifier with argument module. 3. Return the list concatenation of specs 1 and specs 2. Import specifier, imported binding. 1. Let local name be the sole element of bound names of imported binding. 2. Let entry be the import entry record, module, local name. Local name, local name. 3. Return entry. Import specifier, module export name as imported binding. 1. Let import name be the string value of module export name. 2. Let local name be the string value of imported binding. 3. Let entry be the import entry record, module, import name, local name, local name. 4. Return entry. 6. 2. 3. Export syntax. Export declaration. Export from clause. Export named exports. Export variable statement, yield, plus await. Export declaration, yield, plus await. Export default hoistable declaration, yield, plus await, plus default. Export default class declaration, yield, plus await, plus default. Export default, look ahead. Function, async. No line terminator here. Function. Class, assignment expression, plus in, yield, plus await. Export from clause. As module export name named exports. Named exports. Exports list. Exports list. Exports list. Export specifier. Exports list. Export specifier. Export specifier. Module export name. 96. ECMA International 2024. Module export name as module export name. 6. 2. 3. 1 static semantics. Early errors. Export declaration. Export named exports. Comma, it is a syntax error if reference bindings of named exports contains any string literals. Comma, for each identifier name n in referenced bindings of named exports, it is a syntax error if string value of n is a reserved word or the string value of n is one of implements, interface, let, package, private, protected, public, or static. Six, 2, 3, 2 static semantics, exported bindings. The syntax-directed operation exported bindings takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module item list, module item list, module item. 1. Let names 1 be exported bindings of module item list. 2. Let names 2 be exported bindings of module item. 3. Return the list concatenation of names 1 and names 2. Module item, import declaration, statement list item, return a new empty list. Export declaration. Export from clause. 1. Return a new empty list. Export declaration. Export named exports. Return the exported bindings of named exports. Export declaration. Export variable statement 1. Return the bound names of variable statement. Export declaration. Export declaration 1. Return the bound names of declaration. Export declaration. Export default hoistable declaration. Export default class declaration. Export default assignment expression. Return the bound names of this export declaration. Note the above rule means that each reference bindings of named exports is treated as an identifier reference. Note exported bindings are the locally bound names that are explicitly associated with the module's exported names. ECMA International 2024 397. Named exports. Return a new empty list. Exports list. Exports list. Export specifier. 1. Let names 1 be the exported bindings of exports list. 2. Let names 2 be the exported bindings of export specifier. 3. Return the list concatenation of names 1 and names 2. Export specifier, module export name. Return a list whose sole element is the string value of module export name. Export specifier, module export name as module export name. Return a list whose sole element is the string value of the first module export name. 6, 2, 3. 3 static semantics. Exported names. The syntax-directed operation exported names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module item list. Module item list. Module item 1. Let names 1 be exported names of module item list. 2. Let names 2 be exported names of module item. 3. Return the list concatenation of names 1 and names 2. Module item. Export declaration. Return the exported names of export declaration. Module item. Import declaration. Statement list item. Return a new empty list. Export declaration. Export from clause. Return the exported names of export from clause. Export from clause. Return a new empty list. Export from clause. As module export name. Return a list whose sole element is the string value of module export name. Export from clause. Named exports. Return the exported names of named exports. 98. ECMA International 2024. Note exported names are the externally visible names that a module explicitly maps to one of its local name bindings. Export declaration. Export variable statement 1. Return the bound names of variable statement. Export declaration. Export declaration 1. Return the bound names of declaration. Export declaration. Export default hoistable declaration. Export default class declaration. Export default assignment expression. Return default. Named exports. Return a new empty list. Exports list. Exports list. Export specifier. 1. Let names 1 be the exported names of exports list. 2. Let names 2 be the exported names of export specifier. 3. Return the list concatenation of names 1 and names 2. Export specifier. Module export name. Return a list whose sole element is the string value of module export name. Export specifier. Module export name as module export name. Return a list whose sole element is the string value of the second module export name. 6, 2, 3, 4 static semantics. Export entries. The syntax-directed operation export entries takes no arguments and returns a list of export entry records. It is defined piecewise over the following productions. Module. Empty. Return a new empty list. Module item list. Module item list. Module item. 1. Let entries 1 be export entries of module item list. 2. Let entries 2 be export entries of module item. 3. Return the list concatenation of entries 1 and entries 2. Module item. Import declaration. Statement list item. Return a new empty list. Export declaration. Export from clause. 1. Let module be the sole element of module requests of from clause. 2. Return export entries for module of export from clause with argument module. ECMA International 2024 399. Export declaration. Export named exports. Return export entries for module of named exports with argument null. Export declaration. Export variable statement. 1. Let entries be a new empty list. 2. Let names be the bound names of variable statement. 3. For each element name of names, do A. Append the export entry record, null, null, name, name, to entries. Return entries. Export declaration. Export declaration 1. Let entries be a new empty list. 2. Let names be the bound names of declaration. 3. For each element name of names, do A. Append the export entry record, null, null, name, name, to entries. Return entries. Export declaration. Export default hoistable declaration 1. Let names be bound names of hoistable declaration 2. Let local name be the sole element of names. 3. Return a list whose sole element is a new export entry record, null. Null. Local name. Default. Export declaration. Export default class declaration 1. Let names be bound names of class declaration 2. Let local name be the sole element of names 3. Return a list whose sole element is a new export entry record, null, null. Local name. Default. Export declaration. Export default assignment expression 1. Let entry be the export entry record, null, null, default, default. 2. Return entry, 6, 2, 3, 5 static semantics, export entries for module. The syntax-directed operation export entries for module takes argument module, a string or null, and returns a list of export entry records. It is defined piecewise over the following productions. Export from clause. Two. Let entry be the export entry record, module, all but default, null, null. Re. Turn entry, 0, 0. ECMA International 2024. Note default is used within this specification as a synthetic name for anonymous default export values. See this note for more details. Export from clause, as module export name. 1. Let export name be the string value of module export name. 2. Let entry be the export entry record, module, all, null. Export name, export name. 3. Return entry. Named exports. Return a new empty list. Exports list, exports list, exports specifier. 1. Let specs1 be the export entries for module of exports list with argument module. 2. Let specs2 be the export entries for module of exports specifier with argument module. 3. Return the list concatenation of specs1 and specs2. Export specifier, module export name. 1. Let source name be the string value of module export name. 2. If a module is null, then a let local name be source name. B let import name be null. 3. Else, a let local name be null. B let import name be source name. 4. Return a list whose sole element is a new export entry record. Module. Import name, local name, source name. Export specifier, module export name as module export name. 1. Let source name be the string value of the first module export name. 2. Let export name be the string value of the second module export name. 3. If a module is null, then a let local name be source name. B let import name be null. 4. Else, a let local name be null. B let import name be source name. 5. Return a list whose sole element is a new export entry record. Module. Import name, local name, export name. 6. 2. 3. 6. Static semantics. Referenced bindings. The syntax-directed operation reference bindings takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Named exports. Return a new empty list. Exports list. Export specifier. 1. Let names 1 be the referenced bindings of exports list. 2. Let names 2 be the referenced bindings of export specifier. 3. Return the list concatenation of names 1 and names 2. Export specifier, module export name as module export name. Return the reference bindings of the first module export name. ECMA International 2024 401. Module export name, identifier name. Return a list whose sole element is the identifier name. Module export name, string literal. Return a list whose sole element is the string literal. 6. 2. 3. 7. Runtime semantics. Evaluation. Export declaration. Export from clause. Export named exports. Return empty. Export declaration. Export variable statement. Return. Evaluation of variable statement. Export declaration. Export declaration. Return. Evaluation of declaration. Export declaration. Export default voice. Table declaration. Return. Evaluation of hoistable declaration. Export declaration. Export default class declaration. 1. Let value be capital B, I, N, D, I, N, G, capital C, L, A, S, S, capital D, E, C, L, A, R, A, T, I, O, N, capital E, V, A, L, U, A, T, of class declaration. 2. Let class name be the sole element of bound names of class declaration. 3. If class name is default, then let env be the running execution context's lexical environment. B. Perform. Initialize bound name, default, value, env. 4. Return empty. Export declaration. Export default assignment expression. If is anonymous function definition, assignment expression, is true, then let value be named evaluation of assignment expression with argument default. 2. Else let RHS be evaluation of assignment expression. B let value be get value RHS. 3. Let env be the running execution context's lexical environment. 4. Perform. Initialize bound name, default, value, env. 5. Return empty. 7. Error handling and language extensions. An implementation must report most errors at the time the relevant ECMA script language construct is evaluated. An early error is an error that can be detected and reported prior to the evaluation of any construct in the script containing the error. The presence of an early error prevents the evaluation of the construct. An implementation must report early errors in a script as part of parsing that script in parse script. Early errors in a module are reported at the point when the module would be evaluated and the module is never initialized. Early errors in 02, copyright sign, ECMA International 2024. Eval code are reported at the time eval is called and prevent evaluation of the eval code. All errors that are not early errors are runtime errors. An implementation must report as an early error any occurrence of a condition that is listed in a static semantics, early errors subclause of this specification. An implementation shall not treat other kinds of errors as early errors even if the compiler can prove that a construct cannot execute without error under any circumstances. An implementation may issue an early warning in such a case, but it should not report the error until the relevant construct is actually executed. An implementation shall report all errors as specified, except for the following. Except as restricted in 17.1, a host or implementation may extend script syntax, module syntax, and regular expression pattern or flag syntax. To permit this, all operations, such as calling eval, using a regular expression literal, or using the function or regexp constructor, that are allowed to throw syntax error are permitted to exhibit host defined behavior instead of throwing syntax error when they encounter a host-defined extension to the script syntax or regular expression pattern or flag syntax. except as restricted in 17.1. A host or implementation may provide additional types, values, objects, properties, and functions beyond those described in this specificate. Ion. This may cause constructs, such as looking up a variable in the global scope, to have host-defined behavior instead of throwing an error, such as reference error. 7.1 Forbidden extensions. An implementation must not extend this specification in the following ways. ECMA script function objects defined using syntactic constructors in strict mode code must not be created with own properties named caller or arguments. Such own properties also must not be created for function objects defined using an arrow function, method definition, generator declaration, generator expression, async generator declaration, async generator expression, class declaration, class expression, async function declaration, async function expression, or async arrow function regardless of whether the definition is contained in strict mode code. Built-in functions, strict functions created using the function constructor, generator functions created using the generator constructor, async functions created using the async function constructor, and functions created using the bind method also must not be created with such own properties. If an implementation extends any function object with a known property named caller, the value of that property, as observed using, must not be a strict function object. If it is an accessor property, the function that is the value of the properties. Neither mapped nor unmapped arguments objects may be created with a known property named caller. The behavior are built-in methods which are specified in ECMA 402, such as those named. The locale string must not be extended except as specified in ECMA 402. The regexp pattern grammars in 2.2.2 1 and B, 1.2 must not be extended to recognize any of the source characters at Z or raise Z as identity escape, plus Unicode mode, when the Unicode mode grammar parameter is present. The syntactic grammar must not be extended in any manner that allows the token to immediately follow source text that is matched by the binding identifier non-terminal symbol. When processing strict mode code, an implementation must not relax the early error rules of 1, 2, 9, 3, 1. Template escape sequence must not be extended to include legacy octal escape sequence or non-octal decimal escape sequence as defined in 1, 2, 9, 4. When processing strict mode code, the extensions defined in B 3.1, B 3.2, B 3.3, and B 3.5 must not be supported. When parsing for the module goal symbol, the lexical grammar extensions defined in B 1.1 must not be supported. Import call must not be extended. ECMA International 2024 403. 8 ECMA script standard built-in objects. There are certain built-in objects available whenever an ECMA script or module begins execution. 1. The global object is part of the global environment of the executing program. Others are accessible as initial properties of the global ob. Checked or indirectly as properties of accessible built-in objects. Unless specified otherwise, a built-in object that is callable as a function is a built-in function object with the characteristics described in 10.3. Unless specified otherwise, the internal slot of a built-in object initially has the value true. Every built-in function object has an internal slot whose value is the realm record of the realm for which the object was initially created. Many built-in objects are functions. They can be invoked with arguments. Some of them furthermore are constructors. They are functions intended for use with the new operator. For each built-in function, the specification describes the arguments required by that function and the properties of that function object. For each built-in constructor, the specification furthermore describes properties of the prototype object of that constructor and properties of specific object instances returned by a new expression that invokes that constructor. Unless otherwise specified in the description of a particular function, if a built-in function or constructor is given fewer arguments than the function is specified to require, the function or constructor shall behave exactly as if it had been given sufficient additional arguments, each such argument being the undefined value. Such missing arguments are considered to be not present and may be identified in that manner by specification algorithms. In the description of a particular function, the terms this value and new target have the meanings given in 10.3. Unless otherwise specified in the description of a particular function, if a built-in function or constructor described is given more arguments than the function is specified to allow, the extra arguments are evaluated by the calling, then ignored by the function. However, an implementation may define implementation-specific behavior relating to such arguments as long as the behavior is not the throwing of a type error exception that is predicated simply on the presence of an extra argument. Unless otherwise specified, every built-in function and every built-in constructor has the function prototype object, which is the initial value of the expression function prototype, 2023, as the value of its internal slot. Unless otherwise specified, every built-in prototype object has the object prototype object, which is the initial value of the expression object prototype, 2013, as the value of its internal slot, except the object prototype object itself. If this specification defines a built-in constructor's behavior via algorithm steps, then that is its behavior for the purposes of both and. If such an algorithm needs to distinguish the two cases, it checks whether new target is undefined, which indicates an invocation. Built-in function objects that are not identified as constructors do not implement the
If I can get it to like boot up with the scaling applied and startup whatever, there's another thing done. And I think Sublime's set up. So like, I don't know. I'm getting there. This is so boring.
construct internal method unless otherwise specified in the description of a particular function. Built-in function objects that are not constructors do not have a prototype property unless otherwise specified in the description of a particular function. Each built-in function defined in this specification is created by calling the create built-in function abstract operation 1, 0, 3, 4. The values of the length and name parameters are the initial values of the length and name properties as discussed below. The values of the prefix parameter are similarly discussed below. Every built-in function object, including constructors, has a length property whose value is a non-negative integral number. Unless otherwise specified, this value is the number of required parameters shown in the subclause heading for the function description. Optional parameters and rest parameters are not included in the parameter count. Note 1: implementations that add additional capabilities to the set of built-in functions are encouraged to do so by adding new functions rather than adding new parameters to existing functions. '04 Copyright Sign, ECMA International 2024. Note 2: for example, the function object that is the initial value of the map property of the array prototype object is described under the subclause heading array prototype map, callback fn, this arg, which shows the two named arguments callback fn in this arg, the latter being optional, therefore the value of the length property of that function object is 1. Unless otherwise specified, the length property of a built-in function object has the attributes false, false, true. Every built-in function object, including constructors, has a name property whose value is a string. Unless otherwise specified, this value is the name that is given to the function in this specification. Functions that are identified as anonymous functions use the empty string as the value of the name property. For functions that are specified as properties of objects, the name value is the property name string used to access the function. Functions that are specified as get or set access of functions of built-in properties have get or set, respectively, passed to the prefix parameter when calling create built-in function. The value of the name property is explicitly specified for each built-in functions whose property key is a symbol value. If such an explicitly specified value starts with the prefix get or set in the function for which it is specified as a get or set accessor function of a built-in property, the value without the prefix is passed to the name parameter. And the value get or set, respectively, is passed to the prefix parameter when calling create built-in function. Unless otherwise specified, the name property of a built-in function object has the attributes false, false, tr. UE. Every other data property described in clauses 19 through 28 and in Annex B. 2 has the attributes true, false, true unless otherwise specified. Every accessor property described in clauses 19 through 28 and in Annex B. 2 has the attributes false, true unless otherwise specified. If only a getAccessor function is described, the setAccessor function is the default value, undefined. If only a setAccessor is described, the getAccessor is the default value, undefined. The global object. The global object. Comma is created before control enters any execution context. Comma does not have an internal method. It cannot be used as a constructor with the new operator. Comma does not have an internal method. It cannot be invoked as a function. Comma has an internal slot whose value is host defined. Comma may have host-defined properties in addition to the properties defined in this specification. This may include a property whose value is the global object itself. (9.1) Value properties of the global object 191 global this. The initial value of the global this property of the global object in a realm record realm is realm. This property has the attributes true, false, true 191 to infinity. The value of infinity is plus C6 1 6 1. This property has the attributes false, false, false. ECMA International 2024 405. Nine 1 3 nan. The value of nan is nan C6 1 6 1. This property has the attributes false, false. Configurable force 191 4 undefined. The value of undefined is undefined C6 1 1. This property has the attributes false, false, false. (9.2) Function properties of the global object. Nine 2 1 eval x. This function is the %eval %intrinsic object. It performs the following steps when called. Return. Perform eval x false. False 192 1 1. Perform eval x strict caller direct. The abstract operation perform eval takes arguments x, an ECMA script language value, strict caller, a boolean, and direct a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. One. Assert. If direct is false, then strict caller is also false. 2. If x is not a string, return x. 3. Let eval realm be the current realm record. 4. Note: in the case of a direct eval, eval realm is the realm of both the caller of the eval and of the eval. Function itself. Five. Perform. Host ensure can compile strings, eval realm, x, direct. 6. Let in function be false. 7. Let in method be false. 8. Let in derived constructor be false. 9. Let in class field initializer be false. 10. If direct is true, then let the CNV-rec be get this environment. B if the CNV-rec is a function environment record, then I let F be the CNV-rec. 2. Set in function to true. 3. Set in method to the CNV-rec has super binding. 5. If F is derived, set in derived constructor to true. V let class field initializer name be F. V. If class field initializer name is not empty, set in class field initializer to true. 11. Perform the following sub-steps in an implementation defined order, possibly interleaving parsing and error detection. A let script be parsed text, string to code points, x, script, b if script is a list of errors, throw a syntax error exception. C if script contains script body is false, return undefined. D let body be the script body of script. E if in function is false and body contains new target.
This can take forever to set up.
If in method is false and body contains super property, throw a syntax error exception.
I think I'm trying to set stuff up offline.
Structure is full.
Or at least some of this stuff.
Throw a syntax error.
It's taking forever. It's like a waste to like stream because I don't know, it's taking forever to get set up and stuff.
Class field.
So I'm like done for now until next stream.
True. Throw.
I'll have most of this set up. Most likely. Or not. Probably. Who knows?
If strict.
I gotta get this stupid key input working. I don't think this will work on first try. Chatbot saying to use
13. Else. Let strict eval be as strict.
X rained up. I don't know. Maybe it'll work, maybe it won't. I'm gonna try to get it working, whatever, and then next stream, possibly start programming. Or not start, finish up where I left off. And need some water. So I don't know. So like, I'm gonna let the timer run on for 10 minutes so it ends the whole stream or whatever. And I need some water. So I don't know, peace.
Note: if direct
I really need some water.
text will be the execution context that performed the direct eval. If direct is false, running context will be the execution context for the invocation of the eval function. (16) If direct is true, then A let lexi-env be new declarative environment. Running contexts lexical environment. B let vari-env be running contexts variable environment. C let private env be running contexts private environment. 17. Else. A let lexi-env be new declarative environment. Eval realm B let vari-env be eval realm. C let private env be null. 18. If strict eval is true, set vari-env to lexi-env. 19. If running context is not already suspended, suspend running context. 20. Let eval context be a new ECMA script code execution context. 21. Set eval context's function to null. 22. Set eval context's realm to eval realm. 23. Set eval context script or module to running context script or module. 24. Set eval context's variable environment to vari-env. 25. Set eval context's lexical environment to lexi-env. 26. Set eval context's private environment to private env. 27. Push eval context onto the execution context stack. Eval context is now the running execution context. (28) Let result be completion, eval declaration instantiation, body, vari-env, lexi-env, private env, strict eval. 29. If result is a normal completion, then a set result to completion, evaluation of body. 0. If result is a normal completion and result is empty, then a set result to normal completion, undefined. 31. Suspend eval context and remove it from the execution context stack. 32. Resume the context that is now on the top of the execution context stack as the running execution context. 33. Return result. Nine, 2, 1. To host ensure can compile strings, Corley realm, parameter strings, body string, direct. The host-defined abstract operation host ensure can compile strings takes arguments Corley realm, a realm record, parameter strings, a list of strings, body string, a string, and direct a boolean, and returns either a normal completion containing unused or a throw completion. It allows host environments to block certain ECMA script functions which allow developers to interpret and evaluate strings as ECMA script code.